Hello and welcome to section 6.1, which is on the polygon angle sum theorem. So theorem 6.1 is the polygon angle sum theorem. It states that the sum of the measures of the interior angles of an n-gon is n minus 2 times 180. And we did this in 8th grade for sure, possibly 7th grade, just to figure out how many total degrees there are in any polygon. So what is the sum of the interior angle measures of a 17-gon? We're just going to go ahead and follow what that little equation says. 17 minus 2 times 180. 17 minus 2 is 15. 15 times 180 . 1700. No, 2700 degrees. So that works for any number of sides. The n minus 2 is basically how many triangles that figure would make if you cut it apart diagonally. It always makes 2 less triangles than the figure has sides. Equilateral triangle. Equilateral polygon, polygon with all equal sides. Equiangular polygon is a polygon with all angles congruent. So a regular polygon is a polygon with all equal sides and angles. So it is both equilateral and equiangular. Some of these words we should have heard previously. The corollary to the polygon angle sum theorem. The measure of each interior angle of a regular n-gon, the key here is that it's a regular one, meaning it has all equal angles. Regular n-gon is n minus 2 times 180, so the same formula we just did, and then you divide it by the number of sides, which is also the number of angles that it would have. So we're just adding a step. We want to know what each angle is, not what the total number of degrees is. So on this one, what is the measure of angle G in the quadrilateral EFGH? Excuse me. The first thing that you have to do is figure out how many total degrees you have. So it has 4 sides. So we're going to go 4 minus 2 times 180. 4 minus 2 is 2. 2 times 180 is 360. So I know that I have 360 total degrees in there, and I have some of the angles given. So I have 120, 85, and 53. So I have 258 degrees that are already taken by the other angles. I go ahead and subtract that. What do I have left for the measure of angle G is 102 degrees. So 2 steps there. I had to figure out the total number of degrees that were in that quadrilateral, and then add up what I had, subtract it from the 360 to get my one that was left. Theorem 6.2, polygon exterior angle sum theorem. So the sum of the measures of the exterior angles of a polygon, having 1 at each vertex, is 360 degrees. So what is the measure of an exterior angle of a regular nonagon? Well, we know that it can only equal 360 total based on what this theorem says right here. And I have a nonagon, which is 9 sides, so each one is going to have to be the same. You divide it by 9 and you're going to get 40. So each one is 40 degrees. Because it said it was a regular one, you can figure that out. If it was not a regular nonagon, you can't figure it out that way. You'd have to actually figure out what the inside ones are, and then you could figure out the outside and go from there. So on the next one here, find the value of each variable. So these are all outside angles. So I have an x, a 2x, a 3x, and a 4x. And I know that they have to all equal 360 added together. So I have x plus 2x plus 3x plus 4x equals 360. based on that theorem we just went over. So I have 479, I have 10 x's, and that equals 360. Divide by 10, so x equals 36, which would make 2x equal 72. 3x would equal 108, and 4x would equal 144. And if I added those all up, guess what they better add up to? 360. Because there is only a total of 360 degrees and all exterior angles added together. So bring that information with you, and we'll talk about it more the next time I see you. Have a good night.